File sharing protocols are communication methods that enable different devices or systems to share and access files over a network. These protocols define how data is transmitted between systems and how files are managed on the storage server. Below is an overview of the most commonly used file sharing protocols. SMB is one of the most widely used protocols for sharing files and resources like printers over a network, especially in Windows environments. It's a file sharing protocol that allows applications to read and write to files and request services from server programs in a computer network. SMB allows computers to communicate by sharing access to files, printers, and other network resources. It works over TCP/IP and uses ports 445, direct, and 139, NetBIOS. Key features include file sharing across local and wide area networks, support for user authentication, encryption and access control, the ability to share printers over the network, and enabling discovery of devices in a network. Common use cases include Windows-based networks, file sharing in businesses or offices where multiple users access files stored on a central server. Versions include SMB 1.0, which is obsolete and insecure, and SMB 2.0 and 3.0, which are faster, more secure, and efficient. An example is a Windows computer sharing a folder on a network, and other Windows or even Mac OS Linux computers can access and modify files within that folder. NFS is a file sharing protocol developed by Sun Microsystems and primarily used in Unix, Linux environments. It allows different systems to share files over a network as if they were local files. NFS allows a server to share directories and files, which clients can mount and access as part of their local file system. It communicates over TCP/IP and typically uses port 2049. Key features include cross-platform compatibility, enabling network clients to access remote files as if they were stored locally, being stateless, and being efficient and scalable for large-scale file sharing. Common use cases include shared network drives in Linux Unix environments and large-scale enterprise systems and data centers. An example is a Linux server sharing a directory, and other Linux or Unix systems can mount that directory as if it were part of their local file system. AFP, a file sharing protocol used in Apple Mac OS systems, allowing file sharing over a network. It was the standard Apple protocol before SMB became more widely supported in recent versions of Mac OS. AFP works over TCP/IP and allows Apple devices to access files stored on a network device, such as a file server or NAS. AFP uses port 548 for communication. Key features include tight integration with macOS, support for file permissions and resource forks, and file locking to prevent conflicts when multiple users access the same file. Common use cases include Apple ecosystems in homes and businesses that rely on Mac computers and integration with legacy Apple devices. An example is a Mac computer sharing a folder, and other Macs can mount and interact with the shared files using AFP. FTP is one of the oldest and simplest file sharing protocols used to transfer files between computers over a TCP/IP network. It is commonly used for uploading and downloading files to and from a server. FTP operates in a client-server model, where the client requests files from a server, and the server responds by sending or receiving files. FTP communicates over ports 20, data, and 21, control. Active mode and passive mode are two different methods FTP can use to establish connections. Key features include primarily transferring files between computers, standard FTP not providing encryption, though FTPS and SFTP offer secure alternatives, and requiring a username and password for access, though anonymous FTP is also supported. Common use cases include website management and transferring large files between systems. An example is a website administrator uploading a file to a web server using FTP. SFTP is a secure version of FTP, which uses SSH, Secure Shell, to encrypt the data transfer between the client and server, ensuring confidentiality and integrity. SFTP operates over an encrypted SSH connection, typically using port 22. It provides a secure method for transferring files, listing directory content, and managing files on the remote server. Key features include encryption of all data using SSH, requiring SSH authentication, and allowing file management in addition to file transfer. Common use cases include secure file transfer for sensitive data and remote administration for file management on servers, particularly in enterprise environments. An example is a system administrator securely uploading a file to a server using SFTP. WebDAV is an extension of HTTP that allows users to manage and edit files stored on web servers. It's often used to create a shared environment for collaboration and document management. WebDAV allows users to mount remote file systems and access files through HTTPS. It operates over port 80 HTTP or port 443 HTTPS. WebDAV allows for file locking, metadata management, and versioning, making it ideal for collaborative environments. Key features include users being able to read, write, and delete files, manage directories over the web, support for versioning and locking of documents for collaborative editing, and availability of WebDAV clients for all major platforms. Common use cases include collaborative file sharing and document management and web-based applications that require access to remote files. An example is a team collaborating on documents stored on a WebDAV server, with each user able to edit files and manage file versions securely. Choosing the right file sharing protocol depends on your environment and use case. SMB is best for Windows environments. NFS is ideal for Unix Linux file sharing. AFP is suited for Apple-based networks. SFTP is suitable for file transfers, with SFTP being the more secure option. WebDAV is perfect for web-based collaboration and document management. Each protocol has its strengths and specific use cases, so selecting the right one depends on the operating systems you're using and the level of security and functionality you require.